guys, welcome to Not So Nerdy channel. Today we are solving the 19th question called minimum stack. So I hope you have gone through my previous video based on stacks so that it will be easier for you to solve the question. So design a stack that supports push, pop, top and retrieving the minimum element in constant time. Implement the minStack class. MinStack initializes the stack object. Void push int val pushes the element val onto the stack. Void pop removes the element on the top of the stack. Int top gets the top element of the stack. Int get min retrieves the minimum element in the stack. And you must implement a solution with O1 time complexity for each function. So here's a short example. They have given this input and your output is this. So you are first creating a min stack, then you're pushing the values -2, 0 and -3. You're pushing each one of them, then you're getting its minimum, then you are popping it, then you're getting the top, and then you're getting the minimum. Okay, so here is a short example explanation for it. So how are we going to solve this question? They have already told us that we have to create a min stack apart from the stack. So why are we going to use minimum stack? Let me explain you a little bit here. So suppose you, I'll take the same example. It's -2, 0 and -3, right? So we are pushing -2, 0 and -3. So you already have a stack, okay, with sorry for making it messy. So you have -2, then you push 0, then you push -3. Now here, when you remove the top element, when you pop out the top element, you right now your minimum is -3 and you know that, okay? When you pop this out, you see that, okay, how are you going to get -2 as your minimum? You have to go through each element in the stack, and that won't be a constant time. It will be on, the number of elements which are there in the stack. So your condition is that you want to retrieve the minimum in O1 time complexity, like for each function, right? So that is why we are going to keep another track of the elements. So when we push -2, we get -2 in our minimum stack. Okay, minimum stack. Then when we push 0, we still have our minimum stack. We compare the values, that which one is minimum out of the both, and you store -2. And then we push -3 on getting -3. So we update our values each time in minimum stack. And on removing -3, we pop it from minimum stack as well. So you know that, okay, now your minimum element is -2 at 0. Your 0 is the topmost element, but your minimum element is -2. That is why you need to have two stacks, okay? So let's try solving it. So we'll declare two stacks here. Self.stack, self.minimum stack. Okay. Now we want to push the elements and return nothing. So these are like a few functions, right? They have given us, and we just have to, like make these functions. So first we will push whatever element is there in our stack. So self.stack.append val. So we are pushing our value in the stack, but now we want to update our minimum stack as well. So how are we going to update it? You add min stack.append val. But we are not updating our min stack directly, right? We are going to compare which one is the minimum. So how? We are going to update our value as minimum of value, comma, the element which is at the top right now. So we are going to compare it with self dot minimum stack minus 1. We are comparing the topmost element of minimum stack. Like here we are comparing it with this. We added minus 2. Now we are adding 0. Now from between 0 and minus 2, from the topmost element, we are comparing that which one is lesser, and that one will get added to your minimum stack. So that is why here we are comparing the we are updating our value with the minimum value, and then we are storing it our min stack. So if your min stack exists right now, so self dot min stack, if there is like anything in, right, else we are simply keeping it as val. Okay, yeah. Now we have to pop the elements. So for popping, we saw that we are popping from both the stacks. So self dot stack dot pop, and we are popping it from min stack as well. So self dot min stack dot pop, and we are retrieving the topmost element here. So we are going to do return self dot stack minus 1. Okay, these are like the direct notations, we don't have to worry about it. And here we are, for getting the minimum, we will use minimum stack. So return self dot min stack sorry minus 1. Sorry, yeah. So we have passed here, and like okay. So I hope you get the So I hope you get the solution, and yeah, feel free to ask your doubts. And this is a very basic thing, like popping and pushing and getting the topmost element, and I've talked about it in my previous video as well. Go through that, and yeah, thank you so much. Feel free to ask your doubts. Yeah, bye.